What's good, Grizzlies? I hope you had an excellent weekend. Hey, we've got an assignment today where we're doing some more graphing trig functions. On Thursday is our very first quiz of the year. It's optional. If you don't take it, it won't hurt your grade, but an opportunity to bump your grade up. It's just gonna be Thursday only. You could take it 8 a.m. as soon as it's posted or 10 p.m. at night, but after Thursday, it will not be available. And then after that, guys, we got 2 more weeks of school and assignments, and that's it. So a little bit of time left to bump your grade up. If that's what you're trying to do, you could always hit me up if you have any questions. Let's get started with today's lesson. So last week we discovered the sine curve and what it looks like. Today we're gonna introduce some cosine. It's almost the same thing. And we're gonna deal with some shifting left and right and up and down as well. So first, let's draw the general equations of these functions. The first one is a sine of b x minus h plus k. Again, you know what the a value does. It's the amplitude. We talked about that last week where it can stretch it up and kind of squash it down, give it a vertical shrink. The b value right here tells us how long one period or one cycle is. And then this you know from earlier, h moves the graph or shifts it left and right, and k will shift the graph up and down. The equation is exactly the same for cosine. So these are the 2 equations that we're looking at. First, let's review again the unit circle and how we're graphing this thing. So again, the easiest points are right here at 1, 0, negative 1, 0. Because this is a unit circle, we know that the radius is 1. And we also remember any angle that we take, the sine of that angle deals with the y-coordinates. That's what we graphed last week. The cosine would deal with the x-coordinates. Let's first start with the OG original parent functions, and then let's try a few examples of some tricky ones. We'll have you try a few out of the book and call it a day. All right, let's start with what we did last week. This is the sine of x. So right away, I can see that the amplitude is 1, which means that the highest this graph will go from the middle is positive 1, and the lowest that'll go from the middle is negative 1. Also, the b value here is 1. So that means that my period, one cycle, is going to equal 2 pi divided by the b value, which equals 2 pi. That means when I make my 4 marks here, the final mark is 2 pi. That's one cycle of this graph. What would be half or in the middle of 2 pi? Yeah, that'd be 1 pi. What would be half or in the middle of pi? That would just be pi on 2, pi divided by 2. So here's a quick way, easy way to label my graph before I start drawing points. If this is 1 pi over 2, this is 2 pi over 2, that makes this point 3 pi over 2. Then I can look at my unit circle as a reference to help me graph these points. At 0 degrees at the very beginning, I can see that the y-coordinate is also 0 for sine. When I go to pi over 2 or 90 degrees, the y-coordinate goes up to 1, and then this thing roller coasters, right? At pi, it comes back down to 0. 3 pi over 2, the y-coordinate becomes negative 1, and then I finish up at 2 pi. So I have this sine curve here, and that thing is going to keep repeating forever in this direction and keep repeating forever in this direction, just up and down the hill. Let's take a look at the parent function for cosine. So my amplitude and period are basically the same, right? The a value equals 1, which means from the middle, the highest this graph will go is 1, and the lowest is negative 1. The period works the same way. The b value, the number in front of x here, is 1. So we have 2 pi divided by 1, which means the period is the same. It's 2 pi. Let's label that. So I have 2 pi here. In the middle of that would be 1 pi. Half of that would be pi over 2. That makes this 3 pi over 2. Does my sketch look absolutely perfect? No, but I'm drawing accurate points and I'm labeling it so it's very clear to see where I'm at. Now, Because we're taking the cosine of the angle this time, which coordinates are we referring to? That's right. Now we're referring to the x-coordinates. So the x-coordinate right here at the very beginning is up at +1. That looks a little bit different. This one started at 0. This one's starting at the top of the hill, +1. As you go to pi/2, the x-coordinate comes down to 0. You can kind of guess where this is going, right? At pi, the x-coordinate is down here at -1. 3pi/2, the x-coordinate comes back up to 0. And then all the way around the circle to 2 pi, the x-coordinate is back to +1. So check out the way this curve is going. Kind of dips down below. And you can see that this is going to cycle again. I started at the top, I ended at the top, and it's just going to keep repeating forever in this direction. It would keep repeating forever in this direction. So this sine curve is exactly the same as the cosine curve, except it's just shifted to the left pi/2. So check it out, the top of the hill is right here. If I just shifted it left pi/2, I would have what looks like a cosine curve. So hopefully you were able to follow along with that. So this is good to have written down. We have sine and cosine. These are the OGs. Let's look at some equations that throw numbers at us and shift them around a little bit. These are good to use as a reference. Let's start with an example here of a cosine function. It says y equals cosine of x plus 4. Right away, I noticed that the a value is 1. The b value, the number in front of x, is also 1. I do not see any parentheses at all, so the h value is 0, which means it's not going to shift right or left. So this plus 4 means it's going to shift in what direction? It's going to take the middle and it's going to shift it up 4. So let's draw an xy axis here. I'm giving myself a lot of room because this middle part is going to get shifted up 4. Let's label it. We got 1, 2, 3, 4, 5, 6, 7. And right here at 4, this is where the middle of my cosine graph is going to be. That's the middle of it, because the graph is getting shifted up 4. The amplitude is equal to 1. So from the middle, it could go up to 5, and from the middle, it could go down to 3. It's going to go a distance of 1 up and down from the middle of my graph. Let's talk about the period. The period here, kind of like what we've seen before, is 2 pi divided by the b value. The b value, this number in front of x, is 1. So the period didn't change much. Again, I've got 4 marks here, and one cycle is 2 pi. Half of that is pi. Half of pi is pi/2. So we've got pi/2, 2 pi/2. That makes this 3 pi/2. Okay, let's start drawing this function and what it might look like. Cosine, I know, starts at the top of the hill. If I look at my OG, original graph, cosine starts at the top, like at 1. But since this middle part got shifted, the top of the hill is right here now, at 5. Which means at pi/2, the graph would go to the middle. And at pi, it would go down 1, which is +3. And then the cycle just keeps repeating. So top of the hill, middle, bottom of the hill comes back to the middle. And then over here, we're back up to the top of the hill. So here's what my cosine graph would look like. And this would just keep going on forever. I just need to graph one period, one cycle. So looking at your OG original graph, this is exactly the same as that one, except the middle was shifted up 4. You can see it right here. The k value was 4. Not too bad. Let's look at a more difficult one. You can try some for homework. Okay, this one's kind of a beast. Looks really tough. There's a lot of numbers, but it's not that bad. These are kind of fun, I think. It's like solving a puzzle. So check it out. We've got an a value of 5. We have a b value of 1/2. And now this says x minus 3 pi, which means the h value is 3 pi. It's going to shift to the right 3 pi. Let's take a look at what's happening here. Okay, Right away, I know that the middle of this graph is right on the x-axis. There's no k value. It didn't get shifted up or down this time. So here's the middle. Since the a value, or the amplitude, is 5, I know from the middle it can go up a distance of 5. That's the top of the hill. The bottom of the hill will be down here at -5. I also want to label my x-axis. So let's talk about the period. This is going to be 2 pi divided by 1/2. So I'm just going to put 0.5 here. 2 pi divided by 0.5 is 4 pi. So one cycle is 4 pi to get through a whole cycle. And that's how I'll label it on my x-axis. One cycle is 4 pi. What would be half of that? 2 pi. What's half or in the middle of 2 pi? That would be 1 pi. So look, we've got 1 pi, 2 pi, that makes this 3 pi. Pretty easy way to label my x and y axis. What is not so easy sometimes is drawing the points in the right place. So this thing is getting shifted to the right 3 pi. What might be easiest first, really lightly in pencil as like a reference point, let's draw where the OG original cosine graph would go. The OG would start at the top of the hill, come down to the middle, down to the bottom of the hill, back to the middle of our sine curve, and then right here back to the top, and we'd have one full cycle. But I'm not going to draw that because this whole graph has to get shifted to the right 3 pi, which means this point at the top where we start, excuse me, we're going to shift to the right 3 pi. So it should be at the top of the hill right here. After I'm at the top of the hill, it comes back down to the middle, right? This is shifted 3 pi, so it should come to the middle. It should look like this. Where would it go after this? Yeah, it'd go to the bottom of the hill, back to the middle, to the top of the hill, and it'd keep repeating, but I'm out of room. I've ran out of room here. Could you do the pattern in the other direction? Could you go backwards? Yeah, I think so too. It's pretty simple. So here I'm at the top of the hill. I'm going to go to the middle of my cosine curve. Then I'd come to the bottom of the hill and then back to the middle, and it would just keep going in this direction. So right here, what we're looking at is a cosine curve that got shifted to the right 3 pi and vertically stretched by 5. Kind of cool. It's kind of cool. So it's kind of a puzzle that we have to solve. Here is a pretty decent strategy. Take a look at your equation, and first let's draw our x and y axis. Let's figure out the amplitude and the period so we can just label it first. Then I'm going to be looking at the h and k values. Does it get shifted up? Does it get shifted to the right? Might be a good idea to draw just the regular OG points first as a reference so you can know how to move them. So we've got 5 problems to try today. Hit me up in office hours or email me if you need some help. Guys, have a good one. We'll see you next time.